Early scientists then knew about compounds like orpiment and realgar, but they did not know about atoms. And the natural question they had about compounds were whether compounds were discrete, like Skittles are discrete particles, or continuous, the way Jello was continuous. And they didn't have Skittles or Jello, so but they knew things about like the forest. Are compounds more like the discrete forest trees, or more like the continuous forest floor? And early scientists solved this problem combining two basic things. First, they knew about numbers. And second, early chemists did not know about atoms, they did know about compounds, but they did know about reactions. So how did they combine these things? Take the forest analogy. A forest floor is 12.4153 ... acres, and the forest trees are 1,182 trees. The first number is continuous. It's a continuous number. The second number is a discrete number. So, if they could get matter described in discrete terms, they would know that matter was discrete, like Skittles. And they knew about reactions. So they knew about compounds like realgar and orpiment, and they actually knew that realgar and orpiment, if you heat it, this little triangle means heated, realgar turns into arsenic plus sulfur, which we now know are elements, and orpiment also turns under heat into arsenic plus sulfur, and that neither arsenic nor sulfur under heat or any by themselves ever transform into anything but themselves. Okay, so what did they then do with numbers in these things? Realgar is always um, 70.029% arsenic by mass, and sulfur mass percent is 29.971%. That's always true for all realgar. All orpiment, so they weighed their arsenic and sulfur, came out, is always 60.903% and 39.097%. And that means that if you have 100 grams of realgar, you would have 70.029 grams of arsenic and 29.971 grams of sulfur. And if you have 100 grams of orpiment, you have 60.903 grams of arsenic and 39.097 grams of sulfur. Now, so far, that doesn't look particularly helpful. It's neither. It's certainly not discrete numbers, but they could play with the math, and this was the trick that eventually early chemists discovered. The early trick is to turn it into in the following way. Don't look at a total sample that's 100 grams. Instead, turn it into a sample that's exactly 100 grams of arsenic. Since the percent of the mass is fixed for both realgar and orpiment, if you have 100 grams of arsenic, that's exactly 70.029%, and that means there are 142.780 grams of in your realgar sample. The 100 grams of arsenic in orpiment, since its O was 60.903%, came from a sample that was 164.196 grams. And now you can figure out how much sulfur you have in. It's 142.780 minus 100, so that's 42.780 grams of sulfur. And 164.196 minus 100, that's 64.196 grams in the orpiment. And they still look like pretty continuous numbers. But the magic happens when you take these grams of sulfur and you take the 42.780 grams of sulfur and you divide it by the 64.196 grams, and you find out it equals 0.666, which is 2/3. And once they saw that they were actually getting the ratio of discrete numbers, well, if you get discrete numbers, whole numbers, that means that matter has to be discrete, which means matter has to be like Skittles. And of course, they didn't call them Skittles, they called them atoms. And this kind of process that I just described is the law of multiple proportions. So knowing very little, early scientists were able to figure out that atoms existed. They were discrete without ever seeing an atom. And that is, of course, a triumph of the human intellect. Nowadays, it's easy to find out whether they're atoms. All over campus, we have machines that can just see atoms. Here, in case you didn't, here's a picture that you can just take on machines that are on campus. It's a transmission electron microscope. I think we have 2 or 3 on campus. If you take the picture of carbon, it looks like this. And if you look at those pictures carefully, you can see the little circles. Those are carbon atoms. So this is a beautiful machine, but it doesn't detract from the great triumph of early chemists into figuring out that atoms really exist.